Today I will be building an environmental monitoring system using Tinkercad. This project is an environmental monitoring system built using an Arduino Uno and LCD displays by interfacing an analog temperature sensor, the TMP36, and a photoresistor LDR sensor. This system provides a real-time feedback on local climate conditions. The Arduino calculates the precise temperature using the linear voltage output of the TMP36 and simultaneously categorize the light intensity as either bright or dark, and the data is refreshed every 500 milliseconds on the LCD display. And for the component requirements, we need one Arduino Uno, one breadboard, one 16x2 LCD display, one photoresistors LDR, one TMP36 temperature sensor, two resistors, one for the 1 kilo ohm resistors, one for 10 kilo ohm resistors, and one potentiometer, and several jumper wires. And for the prototype, we need to connect the displays from the for the displays we need to connect the ground and the VCC, which is the first two pin, to the power. And the V0 we need to connect to the middle of the potentiometer and connect the terminal 1 to the 5 volt and the terminal 2 to the ground. The RS, we need to connect it to the Arduino Uno digital pin 8, and the RW connects to the ground. And the E, we need to connect back to the Arduino Uno pin 9, digital pin 9. And for the next, we will not using the DB0 until DB3, because we need to save space for the digital pin input for the Arduino. So we'll start from DB4 all the way to DB7, which is 4 wires connect to the Arduino Uno digital pins. For me, I'm connecting the DB4 to the pin 10, and DB5 to 11, DB6 to 12, and DB7 to pin 13. And next, for the last 2 pin, we need to connect the LED anode to the 5 volt and the LED cathode to the ground, and while connecting the LED cathode to the ground, we need to put an 1 kilo ohm resistors to connect it, just like this. And for the LDR potentiometer, we will connect one of the terminal to the 5 volt power and another one to the ground along with a 10 kilo ohm resistors. And we need to connect the analog A0 to the ground side of the potentiometers, as you can see here. And TMP36 temperature sensors connect both the power and grounds to the 5 volt and the ground, and connects the valve to the analog A1. So for the coding, let me make it bigger so it's easier to see. So first we need to include the library for liquid crystal, which is the LCD display. We can include a library by clicking these icons here and just click the include button. It should just show up at the code. And we need to define the connector pin for the LCD displays, starting from 8 to 13 pin. And we need to constantly define the temperature pin for A1, which is the temperature sensor, the light pin for A0, which is the LDR photoresistors. Setup sections, we need to start the LCD by putting this LCD begin 16x2, because this LCD is 16x2 column display. So we put 16 16 and 2, and followed by LCD clear, and of course start the serial begin because we need to print the data on the serial monitor. Okay, for the looping section, we need to first set the temperature logic and equations. Here we need to set the temperature reading equals to the analog read of the temperature pin, and here the float voltage means the voltage will be floating point numbers, and this here is voltage equals to temperature reading. Okay, and here is divided by 5 times 1024. Here's the equation, and here followed by float temperature Celsius, and for the temperature Celsius we need to put this equation, which is the voltage minus 0.5. the voltage is already defined here. We need to minus 0.5 divided by 100, so we can get the degree Celsius temperature. And the light logic here is to first define the light readings equals to analog read light pin, so it will read the data, analog data transfer from the light pin. And here to set the light status, so if the light reading is over 900 it will show as bright, if it's below 900 it will be dark. So for displaying the result, we need to first set the LED cursor starting from 0, 0 and 0, and next we will print the temperature string, and we need to print the temperature readings on the first decimal place, and we need to print the character C, the degree Celsius. And next we need to set the cursor for the light status. Here is 0, 1, which is set to print the light reading on the second row of the LCD display. And next we'll print the light string, and followed by that the light status, which is either bright or dark. As you can see, we just define it here. And on the serial monitor we'll print the light status showing the actual number of the light readings. Okay, and here is to delay by 500 milliseconds. So now we'll run the things and see what will happen. So as we can see here, if the light was below 900, which if we can see on the serial monitor here, now it's 54, so which is below 900 it will show as dark on the LCD display. If it's over 900 it will show as bright. Okay, for the temperature readings, as you can see, if we can see the temperature reading on the LCD display. Okay, and for the potentiometer we can adjust the brightness for the LCD display. Okay, so this is the project for building an environmental monitoring systems.